Let's practice calculating a left-hand Riemann sum for just the function 3x on the interval 2 to 4. And then we'll think about what happens as the number of rectangles goes to infinity. But just a quick sort of reminder, what this function, right, just has slope 3. So at 2, the height is 6. At 4, the height is 12, right? And so we're just taking a bunch of rectangles here, left-hand sums, boop, right? And so how wide are the rectangles? Delta x, that's b minus a over how many rectangles? So 4 minus 2 over n, delta x is going to be 2 over n. And what's the equation for the left-hand Riemann sum? You might remember it's the width of each box times the sum of the heights of each box. Well, the height of the box, right, is going to be, I'm going to try and step through. The formal equation is the left side plus however many delta x's I'm going. Starting on the left means I starts at 0, and we stop 1 shy of the end. So let's just plug in the pieces we need. Delta x is 2 over n. This sum goes I equals 0 to n. Notice the problem has not given us how many rectangles. Okay, how do you plug this into 3x? Well, we've got 3a, that's 3 times 2. I need the 3n minus 1. 3a, and then plus 3 delta xi, delta x being 2 over n I. Okay, so how do we deal with that? Well, there's sort of two different pieces here. Okay, 2n, I'll just tidy it up for a moment. That's 6 plus 6 over n I equals 0 to n minus 1. Okay, well, imagine if you're adding a bunch of 6's together. It just tell me how many 6's there are. And remember, there were n rectangles. 0 to n minus 1 is n rectangles. So this first piece is just 6n. What about the second piece? Well, notice 6 over n times I. 6 over n doesn't depend on the I. And so we just have a certain number of numbers added together. Okay, so this piece is already taken care of. This sum right here, right, is one of those sums. It's on page 291 in 5.1 in the book. But notice starting at 0 doesn't really matter. Adding 0 doesn't really change anything. And so that equation is going to be n minus 1. That's where we get to. Add 1 times n over 2. That's the equation. Okay, let's sort of think about what happens here. We'll try and put it all together. Let's see, this first part, it's 12 n over n. I've distributed that there. What happens here? Let's see, the n's cancel, the 2's cancel. So now I've got to distribute here. I've got 2 times n minus 1. This is a plus sign. 2 times n minus 1 is 2n minus 2 over just an n. Okay, well, 12n over n, that's just 12, right? Plus, what? 2n over n, that's 2, minus 2 over n. So what does this add to? 14 minus 2 over n. Well, at first you might have thought, wow, that limit's going to be crazy hard. But turns out, if they simplify well, the limit's not actually crazy hard. What happens to 14 minus 2 over n as n goes to infinity? Well, this piece goes to 0, right? 2 divided by 100, a million, a billion. It's getting close there. It's 14. And that's actually exactly what you should expect it to be as the rectangles get narrow. Think about this. This is a rectangle. It's 2 wide. What is it? 6 high? 6 high. That's going to be an area of 12. And you can actually see, oh yeah, there was a 12 there. Oh no, but I forgot this 3. It helps when I distribute. So let me just go back and retrofit it slightly. Notice I said it was 2 times n minus 1. It's 2 times 3 times n minus 1. 2 times 3 is 6. How about that? Who knew? So these should be 6s. I apologize. So let's see. 12 plus 6 is 18. This should be a 6. So this should be 18 and a 6. And I'm hoping the answer is 18 now. Well, let's go see if it actually is. Okay, so this is 2 wide, right? This is height 6 to height 12, so this is 6. What's the area of a triangle? 1/2 base times height. That's 6. Phew, they add to 18, and life is grand.